Hello everyone from the world of industrial automation. My name is Artem Melnik. I am a software engineer with 15 years of experience in firmware development and software for programmable logic controllers, as well as integrating CODESYS runtime into these firmwares. Today I am launching the first season of the engineering series Mars Colony 2.0. Let's divide the Mars colonization plan into 4 stages. The first stage is the initial unmanned ships with robots. Tasks: deployment of solar panels, energy storage, and distribution systems to consumers. The second stage is the construction of a methane production plant, storage, distribution, and fuel transportation systems to consumers, a refueling system for ships, and preparation for landing and launch. The third stage is the construction of a minimal life support system for the first humans. And finally, the fourth stage is the arrival of the first humans at the already prepared base. The full list of subsystems for the automated Mars-based control system includes a central control system. This is global optimization, planning, predictive analytics, and coordination of all subsystems. The second is the energy system, solar panels, batteries, backup generators, a distribution network, and the management of energy generation, storage, and distribution. The first task is that the system must calculate the generation of electrical energy from the solar panels. In simple terms, it needs to calculate the amount of energy produced. The second task is that the system must manage the charging and discharging of the battery. In simple terms, it decides where to put excess energy and where to take missing energy from. The third task is that the system must manage the distribution of available electrical energy among consumers. In simple terms, it decides which consumers to give this energy to. In the following videos, we will proceed according to the following plan. First, we will create a web visualization using the built-in tools of the Linux controller SPC210 from the company akYtec. That is, we will use tools such as Python, HTML, and JavaScript to add dynamics to the user interface, or in simple terms, to make it lively. Let's get started with creating the web user interface, or more precisely, the main control panel for the solar power system. To increase development efficiency, we will use AI, for example, Grok. To start, let's ask Grok to generate an image of the main control panel for us, where we use plain conversational language to say that we need a separate background image with a Martian landscape and a separate image with the corresponding subsystems, where for each subsystem we simply list the data we want to display on our control panel. I've already generated the image, and this is what the final result looks like. Taking all the refinements into account, it took me 5 minutes. And now we feed the final images into Grok and tell it that we want the finished Python web server code using the Flask framework, as well as a ready-to-use HTML file using CSS styles and JavaScript. As a result, I got 3 final files that I need to copy to the PLC. The first file is the Python code, which is our web server. The second is the HTML code, which is our control panel interface. And the third file is the background image of the Martian landscape. Let's copy these 3 files to the PLC using any file manager. And now let's launch our Python web server and see what we've got by entering the IP address and port of our web server into the browser. As you can see, we now have a live user interface for our control panel. For now, I've added one control element for the transparency of all the blocks. By moving the slider left or right, we can see how the transparency of our control panel changes. But I want to note that when you generate code using AI, you should always remember that it is just a tool. And this tool is only effective if it is in the hands of a person who is competent in the field for which the AI is being used. Because if a person doesn't understand the field, they won't be able to see the errors that were made after applying AI. Therefore, you should always check its output for any errors. And now, let's definitely take a look at the Python web server code generated by Grok. First, we import the Flask modules, as well as the module for serving an HTML page, the module for returning data in JSON format, the module for generating random numbers, and the module for working with date and time. Next, we create an instance of the Flask application, create a dictionary with the initial data that will be displayed on the dashboard, set the path for the root URL, and define a function that serves the main HTML page. Directly within this function, we serve the HTML template and pass the previously defined data dictionary into it. We set the path for the PLC data API and define an API function that returns the current PLC data in JSON format. In this function, we create a copy of the dictionary so as not to change the original. Next, the following block of expressions simply simulates data changes by generating random numbers in order to make our user interface dynamic, or simply put, lively. The next expression simply returns the data in JSON format. And the last expression just starts our web server on port 5000 while binding to all available network interfaces in the Linux operating system. Now let's break down the HTML code for the control panel interface. We declare an HTML5 document, language English, UTF-8 encoding, mobile responsiveness, and the browser tab title. We connect Tailwind CSS via CDN for quick styling directly in the HTML file. We connect the chart JavaScript library for charts. We can download all these files locally to the PLC so that we don't depend on the internet. For example, in the custom CSS styles block, we link fonts for headings and the main text. For the main body container, we select the page's primary font, disable horizontal scrolling, remove default browser margins, and set a background image of a Martian landscape generated by Grok. Next, we define style classes for the remaining display elements of our control panel. For example, a class for defining container visualization and managing their transparency, as well as for visualizing circular indicators and the slider control element. For the main body container of the page, we set the default text color to white, and inside, we add another main container for which we allow the use of all available height and set responsive margins. Inside this container, we add a header container and set styles for it that will display the content of the inner blocks as a column on mobile devices and as a row on PCs. In the first inner block, we define the visual appearance of the title and subtitle. In the second inner block, we define the visual appearance of the opacity slider and the three indicators. Inside the main container, we also add two more blocks, where each block will contain three inner blocks, and on mobile devices, each of these three inner blocks will be displayed in a column, while on PCs, all three inner blocks will be displayed as a row. And in each of the inner blocks, we configure the visual appearance of all our indicators, substituting PLC data into them. Let me demonstrate the responsiveness of our interface for mobile devices. That is, if our screen corresponds to a mobile device, then all our blocks will be displayed as a single column. And this is how it will look, for example, on a smartphone. Next, in the script tag, we write the JavaScript code that will execute the logic not on the PLC, but on the client device where the browser is running, just like all the other scripts we connected earlier in the header of the HTML file. At the beginning of this script, we find the HTML elements for the transparency slider and its value. Next, we define a function for setting a new transparency value, in which we set a new value for all HTML elements with a special property. We defined this CSS variable earlier in the glass style class, and in this function, we also update the text next to the slider. Then, using this function, we set the current slider value when the page loads, and we also define the same function as the event handler for changing the current slider value. Next, while just using static data for now, we create a bar chart object and a line chart object. Then, we define a function to update all PLC data on the page, in which, by analogy, we look for the corresponding indicator HTML element and substitute the current value into it. And the last expression sets a 1-second cyclic interval for requests from the browser client to our web server, and upon receiving the response with the current PLC data in JSON format, we convert this format into a JavaScript object and call the function to update all PLC data on the page, passing the received object as input to this function. In the next video, using the built-in inter-process communication mechanisms of both CODESYS and Linux, we will transfer data between the main CODESYS task and the web visualization task implemented in Python. Friends, an important point: if you are watching my videos in your native language, be sure to rewatch them on the CODESYS_akYtec_en channel. Why? First, all current, modern technical documentation is written in English. Second, rewatching the same material in English is one of the fastest and most effective ways to level up your technical English. So, subscribe to my English version of the channel, CODESYS_akYtec_en, and rewatch them. Our channel has the exclusive right to offer a 35% discount promo code for the SPC210 and I/O modules from akYtec. And don't forget to subscribe to our YouTube channel so you don't miss the next videos, and also hit the like button if you enjoyed this one. That's all for now. See you in the next video.